third example that we want to cover off today, we want to determine which type of equation and actually make an equation um, based on a situation that we're given. So we've already looked at using simple exponential equations for either increase or decrease, and we've looked at doubling time and half-life. So we want to be able to substitute in values from a word problem or his actual situation, and then plop those into an equation, into the appropriate equation. So let's take a look at example number 1. It says that 8 bacteria doubles every 5 days. Okay, well, if it has the word doubles in it, then it's a doubling time formula. So our equation for doubling time is going to be P is equal to PO times 2 times T over D, whatever D happens to be. So we know, we don't know what P is, so we can just leave that as P. Our PO, or our initial population, is 8. The T, we don't know what the T value is. We don't know what the actual amount of time has gone by, so we just leave that as T. And we know that the actual doubling time, the D value, it says that it doubles every 7 days. Okay, so we can substitute these values into the formula to give us our formula for doubling time for these 8 bacteria. So our formula is going to be P is equal to 8 times 2 over T to the exponent T divided by 7. If we look at the next situation, it says we've got 700 milligrams that has a half-life. Okay, and again, in the question it tells us that we're using half-life. So it's got a half-life of 350 years. So because it's a half-life question, our half-life formula is going to be m is equal to mo times 0.5 to the exponent t over h. Okay, so in this case, we don't know what m is. That's still a mystery. We know that our initial starting value is 700 milliliters. So we're just going to put 700 for that. We don't know what the actual time is, so we're going to leave that as a variable. But we do know what the half-life is, and it says that the half-life is 350 years. So there's my 350. So if I plop this into the equation, I'm going to end up with m is equal to 700 times 0.5 to the exponent t over 350. If I look here at example number 3, it says that the population, a population of 8,500 that decreases by 9.5% per month. Okay, so it's important to note that this question does not use the term half-life or doubling time. It does, however, say that it decreases or it goes down, okay, or it diminishes or something, or shrinks or something to that effect. Okay, so if it's a decrease question, then we know that the equation is going to be something along the lines of y is equal to a times 1 minus r to the exponent x, however many units of time we've got. So in this case, we don't know what y is, so we leave that as a question mark. We know that a, our initial value, is a population of 8,500 people. Our r value is equal to 9.5%, which we need to convert into a decimal, and as a decimal that's 0.095. And we don't know what our x value is, so that's also going to be a question mark. So our final formula will be y is equal to 8,500 times 1 minus 0.095, 1 minus 0.095 to the exponent x. Now this we can simplify. We can do that operation that's in the brackets. Okay, and I can do 1 minus 0.095. That's going to give me 0.905 to the exponent x. Okay. The last example says that the value of $3,400 that grows at 6% per year. Well, if it grows, that's going to be a simple increase question. It doesn't say it doubles, but it says it grows. So if it's growing, then that formula is y is equal to a times 1 plus r to the exponent x. So in this case, we don't know what our y value is, so we keep that. We know that our initial value, our starting value of A is $3,400. We know that the growth rate is going to be 6%, and as a decimal, 6% is 0.06. And again, we don't know what the time factor is, so we'll just leave that as is. So now we just substitute our values into the equation. So we get y is equal to 3,400 times 1 plus 0.06 to the x. And again, we can simplify that because we can do the operation in the brackets. So y is equal to 3,400 times 1.06 to the x. Okay. So knowing which equation to use based on the words that are in the situation would be really helpful. If you're supposed to use doubling time or half-life, the word problem will use the words doubling time or half-life. And if it simply says that it increases or that it decreases, then you're going to use an increase or decrease formula for that.